Hi students, welcome to my channel Excellent Ideas in Education. Today we are going to solve this case study application of trigonometry problem. A school plans to install a new flagpole in the playground. This is the new flagpole. This is the ground. To determine the ideal height, the mathematics teacher conducts a small activity with the students. A student stands 30 meters away from an existing pole. So 30 meters away from the existing pole. This is the flagpole. So this distance is 30 meters and measures the angle of elevation to the top of the pole as 30 degrees. The angle of elevation to the top of the pole is 30 degrees. So we will join the line. This is given as 30 degrees. The student then walks 10 meters closer to the pole. So student walks 10 meters closer to the pole. So this is 10 meters. And the angle of elevation increases to 45 degrees. So this is 45 degree. A, B, C, D. So this is 10 means this value is 20 meter. First question. Draw a labeled figure representing the situation described above. So this is the first question answer. Second one. Express the height of the pole for the two observations using trigonometric equations. This is the height. We need to find this height. Two observations means 30 degree and 45 degree. Now we will solve this problem. Triangle ACB. So we will take this triangle BCA. This is 30 degree. Whole distance we know 30 meter. This height we need to find. Tan 30 degrees equal to opposite to by adjacent. Angle opposite is opposite. Biggest side is hypotenuse. Another side is adjacent. Opposite is AC divided by adjacent is BC equal to H by BC value is 30. Tan 30 degrees equal to H by 30. Cross this 30 tan 30 degrees equal to H. Next, draw 45 degree here. DCA. This is H. This value is 20 meter. This is 10, right? 30 minus 10, 20 meter. Next, triangle ADB. Tan 45 degrees equal to opposite by adjacent. Angle opposite is opposite. Biggest side is hypotenuse. Another side is adjacent. Opposite is AC divided by adjacent is DC equal to AC is H, DC value is 20. Tan 45 degree. Cross this 20 tan 45 degrees equal to H. You see here, express the height of the pole. No need to simplify this one. This is the answer for second question. Third question. Solve the two equations to find the height of the pole. We got H value. This one we need to solve. H is equal to 30 tan 30 degree. H is equal to 30 into tan 30 is 1 by root 3 equal to 30 divided by root 3 into root 3 divided by root 3 equal to 30 root 3 divided by 3. Cancel 10. So 10 root 3. 10 root 3 how we will write? 10 into 1.732. Root 3 value is 1.732 equal to 17.32 meter. Next, this H value 20 tan 45 degrees equal to H. 20 into tan 45 is 1 equal to H. So 20 meters equal to H. We got height of the pole. One height is 20 meter, another height is 17.32 meter. Next, if the school decides to install a new flagpole that is 1.5 times the height of the existing pole, what will be its height? Next, height of new flagpole equal to 1.5 times in the height of the existing pole. So height of the existing pole, which one we will take?
We will take 20-meter height, 17.32 as a decimal point. No need to take this one, neglect that one.
Equal to 1.5 into 20 equal to 30 meter. Height of new flagpole is 30 meter. This is the answer. Thanks for watching this video.